Let's take a look at our first example here. And let's actually make a little sketch before we even try and compute some of these things. Okay. Let's just use the fact that we know cosine of theta is equal to 40 over 41, and that theta lies in quadrant 4. Okay. So I'm just really going to make a sketch here in quadrant 4. Here's our axes, and let's sketch in the angle. That looks a little bit better. And all we need to do is just make sure that our sketch is in quadrant 4 and all the math should work out here. There we go. And next, I want to make a picture of a triangle that's based on this cosine of theta is equal to 40 over 41, right? Cosine of theta is supposed to be equivalent to adjacent over hypotenuse, right? That's the ka from SOHCAHTOA. So this is the adjacent side here. This is the hypotenuse. So I'm actually sketching in right now the one side that we don't know yet. This is the opposite side. All right, we do know the adjacent side. It should be length 40. The hypotenuse should be length 41. And actually, I want to sketch in one more thing here. Okay, and so there is our angle theta. Okay. And technically, I called this theta, but this is technically our reference angle, right? Theta, we actually don't know how we end up with this terminal side. It could be that we've rotated this way, that we've rotated clockwise, or maybe we've done multiple rotations before we've gotten to this point. It's hard to say. Okay. We just know where theta lies. That's all we know. Okay. So next, we can start trying to think about maybe then how to compute sine of 2 theta. Well, we need to find an identity that we can use here because we don't have a picture of 2 theta. Okay, we have a picture of theta. So if we can maybe rewrite this sine of 2 theta in terms of just sine theta and cosine theta, we might be okay. As long as we can get rid of that 2 there in the argument, that'll be a benefit. Okay. So I want us to go back up and see if we can find which trig identity we should use. Right, so we're trying to find sine of 2 theta. And I see this identity up here at the very top that is sine of 2 theta. It's equal to 2 sine theta cosine theta. That's going to be the one that we want to use here. Okay, and then if we take a look at the triangle here, then sine of theta is going to be opposite over hypotenuse, but we'll have to think about the sign. Okay? And by sign, I mean positive or negative. But we'll get there. We need this side here first. And if we're missing this side, let's maybe call that side B. So we have 40 squared plus b squared is equal to 41 squared. And if we were to solve for b squared, we get b squared is equal to 41 squared minus 40 squared. And let me fix that square. Here we go. And so then we get b is equal to the square root of whatever 41 squared minus 40 squared is, and that happens to be 9. That's the length of that side there. All right, so now let's figure out what sine of theta is equal to. So sine of theta, again, is opposite over hypotenuse, so it's 9 over 41. And I left myself a little bit more room than I needed to here, but I left space here so that we can put in the plus or the minus. We just need to figure out which one it is. Okay. So if theta does lie in quadrant 4, then sine of theta should be negative because we're below the x-axis, right? Sine of theta is the y value on the unit circle. Okay. So I'm going to put in a negative here. And then we have cosine of theta. And we actually already know cosine of theta. It is 40 over 41. And if we multiply all this mess here together, we end up with this fraction here, minus 720 over 1,681. Now, let's try and do the same thing for cosine of 2 theta, because we were asked to find that as well, right? Yeah, cosine of 2 theta. And let's think about what identity we want to use here. Okay. Our goal, again, is just to end up with something with just theta in it. Okay, so maybe sine theta or cosine theta, or maybe even sine squared of theta or cosine squared of theta. Something with just theta as the argument. So now that we're up here looking at our double angle formulas, and again we can see that we have cosine of 2 theta in one of these identities. Let's try and use that one. But note, you can use any of, let me underline some of these. You can use any of these as your right-hand side. It's up to you on which one to use. Okay. Well, I'd say to make things easy, why don't we use this one? This one doesn't even depend on the picture we drew. We could use this trig identity without drawing any picture. Let's go see why. Let's go ahead and move down there. So 2 cosine squared theta minus 1. Okay. Well, we already know that cosine of theta is equal to 40 over 41. So I'll put 40 over 41. And since it's cosine squared, I'm going to square that. And if we get a common denominator and subtract these, or use the math frac button on our calculator, we'll see that this thing here turns into 1,519 all over 1,681. All right, and our last one is actually going to be the easiest one. And you might be wondering, well, why is this one going to be easier? Tangent of 2 theta. Well, it's going to be easier because we already know what sine of 2 theta is equal to and what cosine of 2 theta is equal to. Let's go over here and so we have tangent of 2 theta is equal to sine of 2 theta all over cosine of 2 theta. And sine of 2 theta we found to be this minus 720 over 1,681. And then cosine of 2 theta we found to be this 1,519 over 1,681. And if we keep going here, we can now flip and multiply. So this will be minus 720 over 1,681 times 1,681 over 1,519. And these will cancel here, and we'll be left with minus 720 over 1,519. All right, and that is it for that one.